Hey class, this is Mr. Knockme here, trying to get you ready for your test, so I decided to make a video covering some topics that you might be struggling with. One of the topics that I'm going to be covering today is graphing linear inequalities, basically lines, right? And going into this video, I'm assuming that you already know how to deal with slope-intercept form, which is y is equal to mx plus b, right? Where b is your y-intercept and m is your slope. All right. So let's go ahead and do an example problem here. Let's try to graph 3x plus 4y is greater than 12, let's say, right? So in order for us to graph this, we're going to go ahead and put this into slope-intercept form, by which I'm going to isolate the y variable. So I'm going to do that by subtracting the 3x from both sides, right? You end up with the 3x's canceling out. You have 4y is greater than negative 3x plus 12. Again, we're trying to get it into slope-intercept form, so we want the x term to be in front of the constant term. Divide both sides by 4, and you'll end up with y is greater than negative 3 over 4x plus 3. Right? Now we have our two important terms here. We have one which is, we have this 3 right here, which is our y-intercept. It's where it's going to be crossing the y-axis. And the other important term we have here is the negative 3 over 4, which is our slope. That's how much we're going to do our rise over our run, so we can get our line here. So I'm going to go ahead and get us a nice xy axis here to deal with. That's not what I wanted. Just like in regular class, right? Let's see here. Go ahead and get our xy axis right here. And I'm going to count out my y-intercept, which is 3. So I'm going to go up 3. 1, 2, 3, make a dot right there. And the next dot is going to be based off our slope. Our slope is negative 3, so that tells us to go down 3, and positive 4 in the denominator telling us to go to the right 4. So we're going to go down 3, 1, 2, 3, and then to the right 4, 1, 2, 3, 4. And I'm going to make a dot there. Those are the two dots that help us to draw our line. And then if you want, you could do it again to make sure that you are drawing a straighter line. 1, 2, 3 down, and then 4 to the right. 1, 2, 3, 4. Right? Those are the dots that are contained on our line. Now this is the part that confuses certain students. You want to just draw a solid line all the way through, but that is not something you want to do in this case. The reason for that is because of this guy right here. This inequality is a greater than sign, but not a greater than or equal to sign. If you had an or equal to in there, that includes the numbers that are on the line that is going to be drawn. Let me just draw this for you right now. It'll look something like this. This would be incorrect. When you draw a solid line, this is indicating that all the points that are on this line, all the way through, from top to bottom, are included in your answers. Meaning you can plug in a point on here and it will make this true. But if you pick a point, like for example, this point right here, which is going to be 0, 3, if you take these x and y values and plug them into the problem, you'll see that you'll get something that isn't true. So I plug it back into this equation. If I show that 3 is that greater than negative 3 over 4 times 0 plus 3. You end up with a statement that says 3 is greater than 3. And I'm hoping you're realizing that that just doesn't make sense. 3 is not greater than 3. That's why we do not draw a solid line. A solid line represents that that point is included as your solution. And that is only the case if you ended up with a greater than or equal to, or equal to. You need an or equal to in there to make this a solid line. But since we don't have that solid line, I'm going to go ahead and erase this line. Let's see here. I'm going to go ahead and erase this line right here and draw it how it should be, which is going to be a dotted line all the way through. See? A dotted line. That shows us that those points are close to the solution but not included. Now you're almost done, but you're not quite done. After you graphed your line for inequality, now you need to shade your graph. Your solutions are either on the top side of the line or the bottom side, and it's your job to figure out which way it is. And the way we do that is pick a point that's not on the line, plug it into your inequality, whether it be the original inequality or the slope-intercept form, and test to see if that point gives you a true statement. True statement meaning that you end up with something that makes sense. So for example, my favorite point in this case to test is always 0, 0. It's the easiest one to evaluate. 0, 0. That's my x and that's my y. I'm going to go ahead and plug it into the slope-intercept form. And you'll end up with 0. Is that greater than negative 3 over 4 times 0 plus 3? Do the evaluation. You end up with 0 is greater than 3. And that just does not make sense, right? 0 is not bigger than 3. 0 is not greater than 3. It should be the other way around. So I know that the point 0, 0 is not in my solution set. Therefore, the other points that are on the same side of 0, 0 are also not on my solution set. And you could try that. Pick a point like 1, 0 or 0, 1, or heck, negative 12, negative 12. It's not going to work out. Since I know that it's not going to work on this side, I'm pretty sure that it's going to work on the other side. But if you want to be sure, pick another point and test that point out as well. So let's see here. If I go to 4, 2, which is over here on the top side. These are my x and y values over here. I'm going to go ahead and take it and plug it into my slope-intercept form. Sorry about that. So I tested 0, 0, right? That didn't work. I'm going to go ahead and test it into, I already forgot, it was 4, 2. Go ahead and plug that in. This is my x and y value. I'm going to end up with 2. Is that greater than negative 3 over 4 times 4 plus 3? Simplify this out and you'll end up with 2. Is that greater than 4 and 4 cancel each other out? You're left with negative 3 plus 3. It's a final statement of 2. Is that greater than 0? And yes, 2 is greater than 0. So the point 4, 2, which is above the line, gives me a statement that's true. Therefore, all the other points up here are also true, so I just need to shade up top, like so. And that's how you graph an inequality. It combines the steps from graphing a line, which deals with slope-intercept form, but if you're comfortable with standard form, you can do it that way as well. It's pretty much the same thing. You just have to pay attention to your inequality. If it's greater than or less than, your line's going to be dotted. If it's greater than or equal to, or less than or equal to, your line's going to be solid. And that's a key point. After that, make sure you test your points and see which way you should shade. If you have any more questions, please stop by. Let me know.